In the last section here, we are going to find percent composition. So let's use H2O again. In order to figure out my percent composition, I first have to figure out my molar mass. I'll quickly do that again. So that's the atomic mass. I'm multiplying by 2 because I have 2 atoms. I have 1 atom of oxygen, 2.02 plus 16, 18.02 grams per mole. That's my molar mass. All percent composition is how much mass do I have of a given element in a sample of the whole compound. So we're the percent composition of an element compared to a compound. So first, let's do the percent composition of hydrogen. So in any sample of water, we can figure out how much percent, based on mass, how much percent is hydrogen. Because what we know is that there's always 18.02 grams for every mole. So we don't need to know, if I were to measure the mass of this sample of water, I wouldn't need to do that. I don't need to measure this mass of water to figure out the percent composition of hydrogen in that water, because I already have this piece of information using the periodic table. For every 18.02 grams of H2O, there's gonna be 2.02 grams of hydrogen. So basically, I just have to do the hydrogen mass, divide that by the H2O mass. In here, I have 2.02 grams. In all of H2O, I have 18.02. Do a little bit of math, and I get 11.2%. In every sample of H2O, every sample of water, there's 11.2% hydrogen based on the mass. Again, percent composition is a mass value. Now let's do the percent composition of oxygen. Oxygen mass over H2O mass. There's only 1 atom of oxygen. So that's why I'm only putting 16 there. In here, for hydrogen, I have 2 atoms of hydrogen. So that's why I want to account for both of them. For water, or for oxygen, 16 divided by 18.02, I should get 88.2%. What you can also do with percent composition, if you were just given these 2 values, 11.2% of hydrogen and 88.2% of oxygen, you could essentially reverse the math and figure out the formula. However, this is where we have to define the difference between the empirical formula and the molecular formula. Something to keep in mind for percent composition, as of right now, you just have to figure out what the percent composition is of an element in a given compound. You will not be given these percent values and have to work backwards, but you could easily do that. It's not that difficult. But let's go ahead and just define the difference between an empirical formula and a molecular formula. For water, for H2O, it is both empirical and molecular. Empirical just means it's the lowest ratio of the amounts of atoms. If I had some made up compound like H4O2, let's say that was some other compound in the world, this would be its molecular formula. But H4O2, its empirical formula is still H2O, because empirical is talking about the lowest ratio between atoms. So that's all the material that I'm going to go over in this video. If you have additional questions, please let me know. This last set of homework problems will go over some percent composition stuff. But if you have additional questions, just let me know.